So as far as the DMA execution is concerned, it is a process of transferring of the data from the peripheral device to the system memory with the help of DMA controller. And we have the different modes in which DMA is used to execute are the slave mode and the master mode. In the slave mode, the DMA controller is treated simply as a peripheral device. And for that, there are certain steps to be used for using the DMA controller as a slave mode. The first and the foremost step is that the microprocessor unit first selects the DMA controller through the chip select signal, and then the microprocessor unit writes the control word in the channel register or the command status registers by using the control signals that are input output read or the input output write signal. In this particular mode, that is slave mode, the output signals of the 8237, for example, A7 to A4, memory write and memory read, remains in the tri-state mode. So in the slave mode, the 8237 controller works simply as an input output unit in which the microprocessor is going to select the controller first, and then it writes the command into the control words. For example, there are many registers, and these control words are written into these registers by using the control signals input output read or input output write. And at that particular mode, in this particular mode, the output signals such as A4 to A7 as well as the memory read and memory write signals are in the tri-state. But what happens in the master mode? In the master mode, means in the very beginning, 8237 works in a slave mode, and once it works in a slave mode, it changes its mode from slave to the master mode, in which once the control word has been written, and based on those control words, 8237 starts its functioning, and it works as a processor instead of the peripheral device. So the mode in which is called as master mode, it comes after the slave mode. So in the slave mode, what is used to happen, we do the initialization process, and whenever after doing this initialization, the 8237 will convert it into the master mode, and in this master mode, it keeps checking for a DMA request. Once it becomes in the master mode, it itself try to check whether any device has put any DMA requests or not. If there is a DMA request which has come from any device, then it has to transfer the data. But the data can be transferred by following a certain number of the steps. What are those steps? What is the step number one? The first step is when the peripheral is ready for the data transfer. It is not necessary that once the microprocessor has written in the slave mode, it has written the control word into the different control registers, and DMA controller is now ready to transfer the data. But it will be not able to transfer the data until unless the peripheral devices are going to give a request to the 8237 that we want to transfer the data. So when the peripheral is ready for transferring of the data, it sends a signal that is called data request signal, that is DRQ, and making this signal high. So when the peripheral is ready for data transfer, it sends a high signal to DRQ. When this DRQ signal has been received by the DMA controller, and it will be sending this request signal through the certain channel, and that channel is enabled, then the control logic of the 8237 is going to put the hold request signal high. And this hold request signal is connected with the hold signal of the microprocessor. So meaning thereby, once the device, a peripheral device who is ready to transfer the data, sends a request signal through the channel to the DMA controller. And once the DMA controller knows that the channel is active and the device is ready for transferring of the data, then it sends the hold signal to the microprocessor with the making the line HRQ high. So once this HRQ line, which is connected with the hold line, once this signal is received by the processor, it will complete the machine cycle, whatever it is doing. And in the next cycle, the microprocessor is able to know that the DMA controller has sent a request. So what it does, the microprocessor unit immediately relinquishes the buses and sends the hold acknowledge signal to the 8237. So this is the process in which the 8237 works. Now, after receiving the hold acknowledge signal from the microprocessor, the DMA starts its operation, and it starts its operation. The first operation, what it is going to do, it asserts first the address enable signal high. Now this high address enable signal, whenever it asserts AEN, that is address enable signal high, whenever this is going to asserted by the 8237, this is going to disable the latch, which is second number of the latch, because the latch can be enabled only when the signal is low. But the 8237 has sent a high signal, high AEN signal, which makes this latch, that is 3732, second number of the latch, it is going to disable it. So it means it is going to disconnect this multiplex bus, that is AD0 to AD7, that is, or you can say A7 to A0 of the microprocessor, and at the same time it is going to enable the first latch, that is 373#1. This latch is being enabled. Why it is enabled? Because it is AN signal is high and it is inverter is connected, so this output enabled. So it means this is going to be enabled. Next, what happens? Next, the 8237 is going to assert the address strobe signal high. This signal becomes high. Whenever this signal becomes high, this latch is going to be enabled. And this latch, since it is connected with the latch number 1, so it is going to enable the latch. And then what it does, it places the content of the data bus, that is D0 to D7. It places the content of this data bus, since this is enabled, places the content of the data bus into the A8 to A15. At the same time, what happens, the DMA also going to output the lower order address, that is A7 to A0 on the lower order address. So once it is going to latch the value and put it into the A8 to A15, and at the same time it is going to latch the value of AD0 to AD7 at A7 to A0. Now, in this way, the total address is now available from A0 to A15. And once this entire address is available on the address bus, the DMA, say this 8237 DMA controller, sends a data acknowledge signal to that particular device who has made a request. So The process is the any device wants to send a request signal. Suppose it is using channel number 0. Once this DMA controller resolves and find that this channel number 0 is active, it sends a hold signal, HRQ signal to the hold of signal of the 8085. Once 8085 has received this hold signal, it will send a HLDA signal. Once this HLDA signal is being received, it is going to activate the AEN signal high, and this is going to activate first latch instead of the second latch. And the next time it is going to make a address strobe signal high, so that whatever is the content of the data bus, that is D0 and D7, it is being latched and placed on the higher order address bus. And at the same time, since this uh, uh, address strobe has been high, and this uh, whatever is available at the data bus from D0 to D7 will be available at A0 to A7. Now, once this whole address is obtained on the address bus, then only the data acknowledge signal is being sent to that particular device by 8237 DMA controller. Now, the DMA controller now continues the transferring of the data by asserting the necessary control signals such as input output read, input output write, memory read, or the memory write until this DAC signal is high. Once this DAC signal is high, this 8237 remains active by using these signal, and by using this signal, it will be transferring the data. So once the data transfer is over, the DMA, that is 8237 DMA controller, it is going to assert end of the process signal low, so that it can be used to inform the peripheral device that data transfer is going to be complete. And the DMA data transfer can also be terminated by sending a low signal that is at EOP from the outside also. That is why it is a bidirectional. Either 8237 can end the process, or any device can end the process. And once the process has been ended, the hold signal which was high becomes low, so that the microprocessor came to know that the DMA request is over and the data is transferred. So again, it takes the control of the all the buses, that is address bus, data bus, and the control bus under its control. So that is the total functioning of the DMA execution, either in the slave mode or in the master mode. Now going to give some more idea of the DMA controller, that as we know that it is used for the high speed data transfer, and in case of DMA, the microprocessor is going to release the control of the buses to the devices which are known as DMA controller. And this controller is going to manage the transfer of the data between the peripheral and the memory under its control, and it is going to bypass the microprocessor unit. And for that particular purpose, as you know, it will be using hold and the hold acknowledge signal. This is the simplified diagram with a DMA controller in which the microprocessor is connected with the DMA controller. This simplified diagram of a microprocessor system with the DMA controller, which is shown in this particular figure, this DMA controller has only one channel. Of course, we know that it uses 4 channels, but for simplicity and the explanation, I have used only one channel here. We have 4 channels, but for the explanation, I have used only one channel. So if there are one channel, and we know that each channel services individual input output devices independently. So I'm talking about one external device which is connected with the one particular channel. And each channel contains certain registers in the form of an address register, control register, count register, and so on and so on. So let us first discuss about the DMA controller, how it works as a slave or as a master, because we know that in the case of slave mode, the microprocessor is going to load the address register, with the starting address of the memory. It is going to load the count register, that how many bytes have to be transferred. It is going to load the control register with the control information. with all these information which is done in the slave mode. Now, for performing the DMA operation, the processor has to initialize or it has to program the input output device as well as the DMA controller. For example, if I say that a bulk data has to be transferred from an input device to the memory by using a DMA, in this case, the processor is going to initialize first both the DMA controller as well as the peripheral device. So what happens? The DMA controller is going to inform about the address as well as the type of DMA as well as the number of the bytes to be transferred to the DMA controller as well as to the peripheral device. When the input output device needs a DMA transfer, it is going to send a DMA request to the DMA controller through this line. This request has been coming from the device. So once this request is being arrived, this request signal has been arrived from this input output port through which the external device is connected. Suppose it is a floppy disk. It wants to transfer the data to a certain memory location. So it will give the information port, and through the port, the request signal will be coming to the DMA controller. When this DMA controller is going to receive this DMA request, what will happen? It will be sending the hold signal to the processor through the system bus. Once once this hold signal has been received by the processor, what it will do, whatever current instruction it is executing, it stops temporarily after executing the current instruction, and the processor is going to release the buses by asserting all its data bus, address bus, control bus into the high impedance state, as well as it is going to send a hold acknowledge signal from the processor to the DMA controller. Once this DMA controller is going to receive this acknowledge signal, it is going to take the control over the address bus, data bus, as well as the control bus, and begin its work as a master. Now the DMA controller sends a DMA acknowledge signal to the input output port, to the input output device through the port, and this DAC signal will inform the device to get ready for the DMA transfer. So what will happen in case of read operation? Suppose there is a read off. For a read operation, the DMA controller outputs the memory address on the address bus and asserts memory read and input output write signal, because we have to do the read operation. So DMA read refers to the reading the memory location, and hence for a read operation, the memory output the data on the data bus, and this data will be written into the input output port. Suppose we have a write operation. Write operation means the DMA controller is again going to output the memory address on the address bus and asserts memory write as well as input output read signal. And then the DMA writes. That whenever we say DMA writes, it refers to the writing the data to the memory. Whenever we say read operation, it means DMA is reading the data from the memory. Whenever it is the write operation, it means the DMA is writing the content into the memory. So therefore, for the write operation, the input output device is going to output the data on the data bus, and this data will be written into the memory. Now, when this data transfer is complete, the DMA controller is going to assert the hold request signal, low hold request signal to the processor. And once this low hold signal has been received by the processor, it came to know that the data transfer operation is over, and the processor is going to take the control over the address bus, data bus, as well as the control bus. Now, there are many ways of transferring the data, because this DMA transfer can be performed to transfer 1 byte at a time or in the form of a blocks. Either it can transfer 1 byte at a time, or it can transfer in the form of a block. I have already mentioned this particular mode of operation. One is cycle stealing process, and another is the burst mode. There are two modes in which this, uh, these are the two basic modes in which the DMA used to transfer the data. So in the cycle stealing process, whenever the CPU is ideal, then the DMA controller utilizes that time during the CPU, the processor is ideal, and used to activate itself and transfer the either 1 byte or 2 byte. And when the CPU or the processor is become ready, it releases. So it in the cycle stealing process, it steals the ideal time of the microprocessor, and then it transfers the data. But it is in the form of a burst mode or block transfer of the data. The DMA controller is going to transfer the data in the form of a block. In that particular case, the hold request will be sent and hold acknowledge is being received, and uh, the processor is cut off, bypassed, and whatever information has to be transferred from one place to another place, it has to be done. So there are two modes, one in which it used to work. One is cycle stealing mode, in which byte by byte transfer used to happen. And second one is the burst mode, in which whole blocks of the data are being transferred. Now, the basic DMA operations. Now, the basic DMA operation has been shown in this particular figure. These figure illustrates how the DMA transfer used to take place, because we know that in the DMA data transfer scheme, or the technique of DMA data transferring, the external device is required, and this external device is used to control the data transfer operation. This external device, which is going to generate the address as well as the control signal, which is required to control the transfer of the data, as well as it is going to allow the peripheral devices to directly access the memory, so that either the peripheral device can copy the data into the memory, or from the memory, the data can be copied to the output device. So this technique is referred to as told you, that it is the direct memory access data transfer, in which this external device, which is going to control all the operations, are known as DMA controller. The external device which is used to control all the operations are the DMA controller. So here we have through the switching circuit, it has been shown that when the DMA does not operate, when the DMA is going to operate. Now you can see here, this is the processor, this is the address latch, this is the data bus, this is control bus, this is the address bus, and this CPU, this processor is connected with the memory. Once this switch is connected with this switch is connected with this switch is connected with this, it means the CPU is directly working with the memory without any intervention of the DMA controller, or the CPU or the processor is working with the data bus, address bus, and the control bus to the peripheral device without the help of the DMA controller. But once the DMA controller becomes in use, depending upon the requirement of transferring the data in the bulk from one place to another place, so instead of this connection, the connection is being changed, and this connection is connected to this. So it means this processor has been disconnected from the memory. This peripheral device is disconnected from the memory, and this memory and the peripheral devices are connected with DMA controller. So in this particular case, when the DMA is not going to operate, suppose we want to transfer a data from the peripheral to the memory, what used to happen, the data is first transferred to the processor, and then from processor, it is transferred to the memory. But in this particular mode, when the DMA controller is under the operation, the data can be transferred from the peripheral device to the memory, or from the memory to the peripheral device using this DMA controller. So in this particular case, the DMA controller is working, is not working, but in this particular mode, the DMA controller is in working. So while working as a DMA controller, CPU remains ideal. Now, what are the step-by-step process of doing the DMA operation? The first is that the direct memory access input output technique. It is going to provide the direct access to the memory while the microprocessor is temporarily disabled. The DMA controller uh, temporarily made a request and try to borrow the address data and the control bus from the processor, and with the help of these buses it is going to transfer the data directly in between the input output device and the memory locations without any intervention of microprocessor. So the DMA data transfer, you can say that it's a high speed. It can also be used for high speed memory to memory, means two different memory can transfer the data in between. And for that particular purpose, two control signals are used for the request and the acknowledge. The first request signal is the hold, which is a bus request signal, and HLDA is a bus grant signal. So what does it mean? It means whenever the controller is sending a hold request, it is requesting for bus to be under the control of the controller. And once this HLDA signal has been received, it means whatever request has been sent by the controller, it has been granted. Now, this hold input has the higher priority than the INTR line and the rest of the non-maskable interrupts of the 8085. The hold is having higher priority than INTR line, as well as all the non-maskable interrupt, that is RST 6.5, RST 5.5, and RST 7.5. Now, these are the certain features, important features of 8237. As mentioned earlier also, that it uses 4 independent channels, allows the external devices to transfer the data directly either to or from the system memory. Means both the things are possible. It is cascadable to any number of channels, meaning thereby, since one 8237 controller provides only 4 channels, it means 4 devices can be connected to the controller, 8237 controller. But if we have many devices, what we can do, the 8237 can be cascaded together, and individual cascading is going to enhance the availability of the services to the different input output devices or the memory devices. It's a high speed data transfer scheme, and it can also do memory to memory transfer, and the capacity of each channel is fully 64 kilobyte. So each channel has a full 64 kilobyte of the address as well as word count capability. Now, as far as the pin diagram of 8237 is concerned, which was discussed in the last also, we have 40 pins in this, and out of these 40 pins, few pins are very important. Besides input output read, besides input output write, memory read, memory write, ready, hold acknowledge, hold request, chip select. Chip select is going to for the selection of enabling the 8237. Then we have this 8279 is written wrong. It is 8237 actually. Clock signal is to provide the clock. I have already explained, but few of the important signal I just want to explain. For example, what is the importance of the clock signal? The clock signal is input. The clock input. This is the input signal to the 8237. This clock input is used to generate the timing signal, which is going to control the operations of the 8237. Besides that, we have some more signal which is important, that is NC signal. NC is the no connect signal, and this is pin number 5, and it used to be open and should not be tested for its continuity. Besides that, we have AEN signal, which is the different signal. So address enable signal it is called, and this address enable signal, it is going to enable the 8-bit latch, which is containing the 8-bit upper 8-bit address onto the system bus, and this AEN can also be used to disable the other system bus drivers. Besides that, we have an address strobe signal that is pin number 8, and this is made active high signal, and which is used to control the latching of the upper address byte. And this DAC is a acknowledge signal which is sent to the device who has made the request. DRQ is the request signal which is being received by the input output devices. A0 to A7 are the address lines. DB0 to DB7 are the output lines, data lines. VCC is for the plus 5 volt, and GND is for the VSS GND is for the ground. So with that, 8237 is about to over. And this is all about the explanation of 8237.